controls, this video clip is a good place to start. So let's get started. Let's begin laying our foundation for our understanding of controls and control systems. We'll begin with the three parts that every control system has. We always have a sensor, or probably more than one sensor, but at least one. We always have a sensor. We have a controller and we have a control device. These three parts are essential to any control system. Regardless of what kind of control system it is, I don't care if it's a control system that was back in 1885 where we got our start, or whether it is the latest direct digital control system that you might encounter tomorrow. All three parts are going to be there, and I cannot overemphasize that. Whenever I go on a service call, I'm always looking for the sensor, the controller, and the control device. Let's talk about sensors a little bit here. Sensors come in different types. You could have a sensor for temperature, for humidity, pressure, flow, or even status. Obviously, temperature is maybe the temperature in a room, or the temperature in ductwork, or the humidity in a room, or the air pressure in a duct, or maybe we're looking at the flow of water in gallons per minute, or the flow of air in cubic feet per minute, or possibly the status. Is a fan on, or a pump on, or is it off? All sensors will take whatever they measure, and they will be either measured in an analog signal or a binary signal. When we mean analog, we mean anything that it's a variable, like temperature is a variable, humidity is a variable. Anything that's binary is an on or off kind of thing. We could also call it digital. Binary and digital mean the same thing. Bi, like in the word bicycle, meaning two wheels. It's either on or off, or it's yes or no, or it's true or false. Or when you buy appliances these days, the appliance has a button on it that says not on and off, but it says 1 or 0. 1 is on, 0 is off. Binary and digital are the same thing. These are going to be inputs to the controller. Now, a controller cannot understand temperature, humidity, pressure, or flow rates. A controller, particularly a digital controller, only understands three things. It understands either a variable voltage, a variable amperage, or a variable resistance. It's an electric kind of device, so it only understands an electric kind of a signal. So the sensor, whatever it measures, whether it be temperature, humidity, pressure, flow, status, whatever it is, inside of every sensor, the sensor must take and change what it measures to one of these three signals, a variable voltage, amperage, or resistance, that can be understood by the controller. The controller software will interpret a voltage to mean a particular humidity, for example. So we might measure humidity in 0 to 100%. Well, then we would take and change that 0 to 100% into a possibly 0 to 10 volt signal. So 0 volts coming into a controller would tell the controller software, well, we have 0% relative humidity. 5 volts coming in from a humidity sensor would tell the controller we have 50% relative humidity, and so on and so forth. The point is here that every sensor, no matter what kind it is, always takes at the sensor and converts whatever it measures into a signal the controller can understand, which is going to be voltage, amperage, or resistance. Now, the controller is going to have the set point in it. This is where the set point, or the desired value that we're trying to maintain, is going to reside. So, for example, if you wanted to maintain 70 degrees Fahrenheit in a room, the temperature sensor here might measure 75 degrees, so it'll send a signal into the controller that represents the 75 degrees, but the controller's job now is to compare the 75 degrees the sensor sent it to the desired value of 70 degrees, which is the set point that we're trying to maintain. The controller then always contains the set point, the value you're trying to maintain. The controller then analyzes and says, well, I am looking for a set point of 70, but I'm getting a 75 degrees temperature coming in, therefore I have a 5-degree error here. The controller then makes a decision and sends an analog or a binary output, depending upon what it's controlling. It sends a signal out to a control device, which is going to take some action to rectify the situation so that we get back to set point. The controller could be operating a control device that's a relay or a starter to turn a fan or a pump on or off. It could be operating a valve, a damper, or a variable frequency drive. These are all examples of control devices here. In the case of the example I was using here, if the temperature sensor says it's 75, sends a signal that represents 75 degrees to the controller compares that 75 degrees to a 70 degree set point. It makes a decision and it sends an analog output to maybe a chilled water valve, and it opens that valve up to begin to give us more chilled water into a coil and begin to move our air temperature back down towards the temperature that we're trying to achieve, which in this case is 70 degrees, which is our set point. So in quick review, we always have these three parts: a sensor, a controller, and a control device. And as we move along into other videos, we'll go into more detail. We need to discuss sensors, the various kinds of sensors and how they work. The various types of controllers, how they receive a signal, how they process the signal, and then send an output to a particular control device. So we'll also be looking at a variety of control devices. So in our videos coming up, we will go into more detail on this, but this is the foundation that we need to lay first in order to understand where we're headed for in the future. Stay tuned.